All right, well, I just want to show the two most, here, I'll write it. The two most important equations for guitarists, but maybe just musicians or instrument builders in general. So one is going to be the pitch frequency equation, and this is going to be ratio plus reference pitch. And so this is going to look like 2, because this is the octave, to the power of x over n. This is going to be number of octave subdivisions and you write tet or Edo here, and then so I want to do that here, and then we can even write out 2 to the power of x over n times, and we can just write 440. This could be a reference. And I mean, this can be anything, you know, if you're like a 432 person, if you are, you can just multiply your ratio by that. And then we're just also gonna even say that this is A, but like this, you know, you could pick A, B, C. Great. Now, I'll zoom out too at the end of this video so it's not just crammed. But ratio plus reference pitch, what this is going to do is essentially generate a scale. What 2 over x to the n is going to do is create a ratio, and even if you use a polynomial like, you know, 2 to the power of ax plus b, you could even do Pythagorean theorem, so you could do ax plus bx, ax squared plus bx, you know, you remember all that jargon from high school. And then over 12. This polynomial, like if we throw in 1 and, you know, say a, b, and c were 0, we just get 0. So depending on what a, b, and c are, this will still give you a number that's going to look like this. And so when we multiply it by a reference pitch, you know, usually we pick one with a 0 or a whole number. It's going to generate irrational values for the rest of our scale. Now, the second equation also makes use of our ratio, but it's going to be a little different. We're going to use L, which is going to be scale length, and then it's going to be L times 1 minus 2 negative x over n. And, you know, this could look like standard guitar scale inch plus 1 minus 2 to the power of negative 1 over 12. And this is pretty much going to give you standard guitar. Now, why are all these even particularly helpful? Well, say you want to rock, you know, a 30-inch scale guitar, but you want to have, let's say, 22 frets. This would not only increase your guitar scale length, but then also increase the number of notes in your scale too. And this is going to give you all the measurements for your frets and all that. And we're building, sorry for that horrible box. You know, it's basically, a lot of it's just going to have to do with either reference pitch or scale length times our ratio. So over here we'll have reference times ratio, scale length times ratio. All right, and I'll do a classic little zoom out and review all this. Sorry, knocking over fast food. Review all this nonsense that I've written down. All right, so a ratio plus reference pitch is going to give us our scale. So if we want a chromatic scale, we'll just make n into 12. If we want an enharmonic scale, we'll make it into 17. If we want 22 equal tet, we'll make n 22, and x is going to be the number that calculates the overall distance that each note is being traveled, and then we multiply that by the reference pitch, and that's going to give us our hertz measurement, our frequency. Now if we want to know the scale length that we're going to achieve all of these notes of our scale in, then we have to take our scale length, which is standard guitar is 25.5. A 30-inch guitar would be like a bass 6 or a super baritone guitar. And then we're just going to multiply that by whichever ratio of scale we're using. So most guitars use 12 tone, and we're going to make the numerator negative. So 2 to the power of negative 1 over 12, and in this context of a ratio is how I get this. So our two most important equations are always going to involve our ratio, which is an equal temperament ratio. And we can get our scale by multiplying the reference times the ratio, and then we can get our scale spacing by multiplying the scale length by the ratio.